Welcome to my physics lair. This is all about practical skills in physics. This will be your AS quantitative task, which will give you 20 marks towards your overall mark of 40 for the coursework section of your A level. So this is important. You get 20 marks for doing exactly what you'd normally do in an experiment. Easy? I hope so. But you need to do all the correct things. Now every time I ring this bell, apart from that time, press pause. And that is something that you can then do some work, read up, have a think, and then press pause again when you're ready, based on whatever I ask you to do. Are you ready to begin? Let's begin. So, I have the mark scheme right here now, telling me exactly what you should have in your work for this answer. Okay? Now, if you do the experiment, and it's obvious you've set up the equipment, and you've got a set of results, then you get a mark. Okay? If you, in your table, look at your table in a minute that you've drawn for your experiment, if you have got at least 6 sets of results, so the thing that you are changing, the variable you change, the independent variable, that should be on the left hand side of your table. And on that side should be very clearly 6 different measurements, and you've got results for those. If you've done that without any help, you get another mark. Easy? So check you've got 6 results. I hope you press pause. Okay, the next thing will be again a measurement you are going to be making of something else, quite simple. Could be the original length of a spring, if that's something you've just done. So you've done that, and again, if you've measured that correctly and you've done it right, there's another 2 marks for whatever the extra measurements should be. Okay, now the other thing is to be aware of is that for your values, if you were given a set of equipment and you could have a maximum and a minimum, whatever those values may be, it could be the masses on the bottom of a spring, you should make sure your results go from the smallest you can have to the largest you can have, and then go up in even steps. So your table of results should have a set of results going up in even steps from the smallest up to the maximum. If you don't do a full range and you only do half of that, you will lose a mark. So you get 1 mark for a good range. Check you have a good range. Remember, whenever you take any reading, do not do it once. It will probably ask you to measure one thing at the start. So whatever that one thing is, check it at least twice more, so at least 3 times. Same for your results. In your table you should have space for repeat readings. Do at least 3. 3 is good, to check that you get consistent and reliable and repeatable readings. If you get a different result for the second one, the third one should confirm which one is anomalous. Otherwise, all 3 could be the same, and yes, then take an average with those 3. But don't include anomalies in the average. So please do repeat readings. If they do not have those in the table, you will lose a mark. Make sure that is good. Okay? Okay, so the big thing about your table is making sure the columns are correct. Now on the left hand side, the variable that you changed, you want to make sure that you have got the correct quantity labelled at the top. That's what it is. Could be, for example, force, and then you have the correct units separated by the correct separator. So for example, it would be force, and that's measured in newtons, and the capital N for newtons is usually separated by a /, or if you prefer to put it in brackets, put it in brackets. So check your table, has it got the correct labels at the top of the column? So on the left for the independent variable that you change, and on the right for the dependent variable that you measure. Okay, any calculations you have to do based on your numbers. So for example, if you were working out force and you originally had mass, doing all your calculations, if they were done correct, then that's good. But the big thing is that you need to make sure that if you are measuring anything, whatever the precision of your measurements is, so if you're using a ruler to measure length and it's in millimetres, your answers in your table should be to the nearest millimetre. If you're using a stopwatch, to the nearest hundredth of a second, they have to be to the nearest hundredth of a second in your results table. And even if they don't have a number of any place value, if they're zeros, if you can read to that precision, then you'd have to put a number like 1.00. Okay, put in all the noughts if that's the case. So check you've done those. If you've done all those correctly, that's 2 marks. Ooh. Okay, now the other thing that you would then start picking up marks for is a graph. Now when you draw a graph, you do it exactly which way it tells you. Normally you'd put the independent variable, the one you change, on the x horizontal axis, but in this case perhaps they want you to do it the other way around. They might want you to plot the quantity you measured as a reciprocal, so 1 over that quantity. They might want you to do one quantity multiplied by another. Whatever it tells you to do, plot that on a graph. You have to fill the graph paper. If you don't occupy more than half of the graph paper, you will not get a mark. And equally that's the same on both axes. And your scale should be sensible. If you go up, say 10 little squares is 3 on your value, so you go up 3, 6, 9, that's a bad scale. If you go up in 6s, for every 10 little squares, that's a bad scale. Go up in 5s or 10s, go up in something where each square is a very clear number that you can definitely use to extract numbers. Okay, so check your scale. Do you have 2 good scales? If you've done that and it fills all of the paper and you've labelled them with the quantity, whatever it is, and the units, even if it's 2 units or 2 quantities multiplied together, make sure your units are there, whatever they may be. So if it's a 4 times a distance, your units are Newton meters. Whatever it tells you to do, do. Check your graph now. Okay, I will check that your graph points are in the right place, and what they do is you check at least 2 points that look a bit dodgy. Okay, if they are correct, you get the mark. If they're not correct, you lose a mark. You should draw a line of best fit. A line of best fit could be a curve or a straight line that at least tries to cover all the points with a smooth curve if it's a curve, or a straight line. If it goes through the origin, think when that value that you change is 0, can the value that you measured be 0? And if it is, you should have a point at the origin. If you don't have a point at the origin and you have a y or x intercept, then perhaps there is a reason why, and that's something you should be aware of from the experiment. So check your line. Okay, if it should be a curve and you drew a straight line, you don't get the mark. So you get 1 mark for your points being right and 1 mark for your line of best fit. Check it. Okay, last thing is the gradient. Okay, whatever your gradient is, you measure it by doing the biggest triangle you can for your straight line. So do it as large as you can. The biggest triangle, the biggest difference in the y-axis divided by the biggest difference in the x-axis, and that will give you your gradient. And whatever the units are on the x and the y-axis, make sure you use those to write down the units of gradient. So the units of the gradient will be whatever's on the y-axis, the units, divided by the units on the x-axis. So you get 1 mark for doing the gradient correctly with the units. Working out and draw all over your Okay, there may be a y-intercept on your graph, and if there is, then that could well be something that you have to use. So you'll look at the y-intercept and get a value, and then it could well ask you to figure out what that means based on the question. So for example, if you were doing something where you had a value for a distance that was the y-intercept, you'd have to look at that and be able to interpret that using the equation you've been given and the equation of a straight line. If it's a straight line, y equals mx plus c. So if you can do that, then guess what? You'd get another 2 marks. That's the only bit that's different to what you've ever been able to do at GCSE. So hopefully that means that by the end of your practical, you would then therefore be able to get pretty much 20 marks. Be aware though, any calculations you ever do, you should be able to justify how many significant figures you do them to, and you can only do it to the limit of your worst readings. So if you can only read something to 1 significant figure, perhaps based on the precision of your device, then that's what your averages should be. Your averages should be the same as the numbers you've used to get them, and if you do that for any averages with the right significant figures for calculations, you get another mark. Good, isn't it? So I hope that helped. You can use this to help you get the marks right when I ask you to write up a practical. And when it comes to revise and preparing for the practical, that is what you would need to do for your quantitative task. I hope that's helped. Enjoy. I'm off to find out more about physics. Until next time.